better so that RX looks above and below the selection. That's going to take frequencies from directly above and directly below the fundamental and harmonics that are selected for this whistle and fill them in when we remove it. So in hitting render, you'll be able to see in the spectrogram display that that whistle has been removed, that big ugly bright streak is gone, and now all there is to do is to play the file and make sure we removed it to our satisfaction. Alright, and what's great about that is not only is the whistle gone, but you can't even tell that anything was there in the first place to be removed. So we'll do a quick before and after. So that shows that spectral repair's algorithm of sourcing content from the rest of your audio file means you're going to be able to remove tones in a completely transparent way and not compromise your actual recording. So that is a super useful tool in a number of music production scenarios. Moving on, we have a guitar solo recording here. I prefer to use the waveform view when we're working with a file that has some distortion or clipping in it. It makes the transients a lot easier to pick out. They're super pronounced, and you'll be able to see the effect of your processing a lot more clearly. So let's listen to the original audio we're working with. Alright, so it's true that this is a crunchier guitar tone, so you're going to want some distortion built into it, but digital distortion is not what we're after here. In these first two dramatic transients, you can hear a little crackle as the signal clips. So we know that there's something in there we want to remove. This is a really good opportunity to demonstrate one of RX7's coolest features. We're going to open up the Repair Assistant. This is another instance of really intelligent technology that the developers at Izotope have incorporated into RX7. Repair Assistant analyzes the audio file you're working with according to which algorithm you select here, and it's going to identify, it's going to look for clicks, clipping, general noise, and hum. Those are four of the most common issues in digital audio. So this is a really good starting point to remove those problematic artifacts or frequencies before you get into more serious editing and mixing. The dialogue algorithm is specifically geared towards spoken word recordings. Music is geared towards musical recordings, and other is useful for like percussive elements or sound effects, things like that. So we're going to select music and start the analysis. The way those modes were developed is our engineers use machine learning. They have fed RX7 with countless hours of dialogue recordings, musical performance, and just general digital recordings of sounds. And that has enabled RX7 to identify patterns, which makes it easier then for RX7 to say, all right, this is a music recording, but there are clearly clicks or pops or whatever that you're trying to get rid of. So, first thing to check out here is you can see that we have the original audio file right here, and then 3 processing suggestions have been made. If you hover over each one, RX will show you the modules that are in use. So for option A, it looks like it's applied declip and mouth declick, that's interesting given that it's a musical instrument recording, but that goes to show you that different modules in RX can be used for different purposes. Option B uses declip and declick, as does option C. So we'll take a listen to option A and see what it did for us. Alright, so that's pretty good. We can compare it to option B. That's also a nice result. I feel like option B maybe removed more content than I wanted to. Option A, I'm going to use that as the processing because it still retains the grit and the crunch of the original guitar tone. It just got rid of that digital clipping that we were experiencing. So when I hit render, you can see the change occur in the waveform. A lot of those transients have been brought down so that it's automatically should be a super clean recording. And we'll just do a quick playback to confirm. Alright, nice and crunchy, but it's not clipping anymore. We like this. This is what we want. Alright, moving on, we have some other pretty cool applications of Repair Assistant. Yeah. Yeah, absolutely. So, the question is, what's the difference between mouth declick and declip? Mouth declick was developed by RX being trained with recordings of the human voice, so that you get it gained the ability to identify clicks that occur in the human mouth. They usually occupy a certain frequency range. Declip was developed specifically for digital clipping, as you can imagine. The content of clipping versus mouth clicks, they differentiate a little bit, and they're different enough that mouth declick is usually a lot more useful in recordings of spoken word recordings, and then declip is targets specific digital clipping. But yeah, again, it shows that the modules in RX are really versatile. It's a lot of fun actually to use modules for purposes other than their intended function. It's a tool that lets you correct problems, yes, but you can also do a lot of creative things. So moving it on to this example, we have moved this fader so that we're seeing the waveform and the spectrogram. And right away there's this nasty orange bar down here at around 50 hertz. That to me indicates that we have some ground hum going on. I'm gonna play it here. Granted, in a trade show environment, it's kind of hard to pick up on that low frequency hum. So hopefully we can get a good example out of it. So you almost feel it more than you hear it. It's just a really low constant vibration, and it's really easy to identify visually. So just to give you an idea of the different things that Repair Assistant can look out for, we're going to click Start Over so that Repair Assistant forgets its previous analysis. Still working with a music file, so we'll keep using that mode, and we're going to perform the analysis again. And if you look at these lists here, it's analyzing for clipping, clicks, hum, and noise. And then you can see it detected the hum, but no noise, no clicks, no clips. That seems accurate to me. Other than the hum, it's a pretty clean recording. So just like before, we'll check out option A, which just applied de-hum. All right, and that works for me. Again, I know it's tough to pick up on whether the hum is or isn't there in an environment like this, but what's cool is when you click render, pay attention to the spectrogram display. That giant orange streak is totally gone. So even if it wasn't a super distracting audible sound, it's going to make mixing much, much easier to get rid of all that low-end content, because if you keep that in, you're going to have to compensate when you're EQing later on, and this is going to save you a lot of time. So taking a listen back, we should be left with a totally clean guitar recording. And so you notice the hum is gone, but we didn't completely kill the low end of the guitar itself. Again, RX's intention is to remove things you don't want while leaving your audio as close to the original as possible, so that you're not getting rid of character that you want your audience to pick up on. So once again, Repair Assistant diagnosed the hum, applied de-hum. It took, subtracting the time it took me to explain it, it took about 2 seconds. So that's a super useful tool for, again, a lot of musical production settings. Yeah,